Okay, we're back. So I just got done recutting everything, cleaning it. So, guide shorter now. Still good on the height. Okay, so I don't know what the hell happened there, but this one didn't like what we had, obviously. So either live with it or you fix it. So you know which way I go. Of course, I had to reclean the head again, obviously. Can't be having an oily, chip encrusted new motor. Oop. Start over with everything. Watch it be way too much this time. Had that happen before. Come on, Scooby, on my way. Okay, another seal. Almost 2 sets now. 7. Only takes 4. Got our number. 430. Top of the chamfer, so there you go. Oh, had to cut it. I don't know why. Oh well, life in a big city. Okay, so now we move on to assembly. The rest of the way. Okay, so this exhaust, we're on the front cylinder. This combination of parts here. It's called a manual spring compressor. This one's an old British one, so it's made for probably Royal Enfields, Triumphs, stuff like that. Works good on our head sportsters too. So I hold the keeper with a finger on the back side. Drop it down in the groove where it belongs. Like that. Then you come by and just drop this keeper here, right on the top. It kind of more or less slides in there. Not quite all the way in there correctly, but it's close. Then you come back with a screwdriver and just poke it into where it belongs. And now it's in there where it belongs. And you unscrew it. Compressor. So you should hold it up in there like it belongs. Keep hearing the rattling noise. It's the other color. And you're all done. Make sure the keepers are all the way in. Look good. Go to the next one. So I don't know if you can find these online. This is a Britex brand, number T138. So you go back in the 60s and you can probably find this. There's probably one out there somewhere, but don't know where. Now this handle here is not stock. I made it. This is twice as big as the one that was on originally. The one that was in here I made a tool out of for pulling cam covers off with. Might be in here somewhere. Don't see it. It was in a different drawer. I loaned it out to somebody and never got it back. Who knows? Yeah, there it is. Cam cover puller for a cone motor. Could be a Sportster, could be a big twin. You need all of those types. These keepers are a little fatter than the Harley ones are, so they don't go in as good. Which means it's harder to put them in. They're the same width as the down groove, so they just don't fit up in there like they're supposed to very easily. You just gotta work a little harder, that's all. Looks like it's going in though. Yep, it's in there. Exhaust port off the edge of the table, it sits flat. Okay, now I take a medium screwdriver, hit on top of each keeper, right in the center. Make sure they're seated. So you hit square on each keeper. Oop, bang, bang. So you can see the split in the keeper. Split's over here going this way, so I hit dead flat on the keeper like that. Just whack on it. Now it doesn't matter if the keepers are not equally spaced. It doesn't matter if you have a big fat gap and no gap. Someone now got on my ass about doing that. That's stupid. They float around where they want to be. It makes no difference. Keeper's either in or it's not. So anyway, these ones are in. So I measure them. See if our installed heights are about where they belong. Looks like we're up there around 260-ish, 5 maybe. I forget what number we're shooting for. This one here is about 270. So I assume we're close. Have to calculate, reverse calculate the numbers to know for sure. We'll go watch the old video. I don't remember what the full number is, but I know how to get the number. It's 0.770 plus 0.05 plus 0.430. We increasing the lift. 1,250. We just made it, see? You notice I added more lift. It's for the bigger cams. Okay, so that one's done. So this is the screw that was originally with this. See the upgrade I gave it? Because this don't work on racing valve springs on my Sportster. This little dinky one, it was just bending like a big S in this thing. You know, plus it was all worn out in here, so I tapped it out to a big size, made a big screw. Now I got a lot more leverage, a lot more strength. I rebent it back straight because it was bent. So every few years I got to rebend it. See, this is supposed to go in line right straight. It was going like out here before. So you put in a hydraulic press and bend it back. And it works good for a few years. And then this one here, I made a tool for pulling the cam cover. You just screw this into your cam cover point plate screws and screw this in. It pops, push into the cam, pulls the cover right off. Works good. And I didn't have to make this piece, which is the hard part. No good for one tool, good for another one. Alright, so now we're back to this. We'll do the next one. Everything's in order over there. Intake, intake. You're going right in the one. I can skip and go the other way, doesn't matter. Come on, Scooby. Scooby is just not happy tonight. He wants to go home. Unless I hold it so I can put my finger on the back side with everything. It's all about how you position things. Here, pop in there. Not quite all in correctly though. Now it is. Weight of the head shoving the valve spring compressor off as I drop the tension down. You want to make sure they're both in there correctly before you get the compressor too far away. Oh, got way too far out. I don't like using grease and stuff to hold keepers in. All it does is make me greasy. I don't like being greasy and oily if I can avoid it. I definitely don't like my tools being greasy and oily. This one does not want to go in there. A bit further down. There it goes. Okay, looks like it's in there. Do our tap tap again. And do our measurement. Ooh, that was way up there. 285. Rear intake, that's why. Yeah, I was down about 265, 270. So this one here, we can probably put that thicker shim on that one, but I ain't doing it now because I have to take it all apart to do that. So we're not going to do that. But there's room to put that 30 in there, so that 10 would be just about right if I did. But that costs another valve seal to do that, so I'm not going to put 2 full sets in this thing. So this bike's not going to be driven that hard. It's plenty adequate. Like I say, these are a lot heavier springs than what those cams need, so we're okay. Alright, so there you go. They're all in there. Here's what the valves look like after they're all in. So it's got a good flow design. So now when you got your heads in here, when these valves open up with this nice parabolic curve I cut in the chamber, the air will flow real nice and cleanly right out of the valve. It'll flow pretty good. The exhaust is not quite cleaned up yet, it's full seat still in there. So once this sinks in some more, probably about another 40 thou deeper, it'll start cutting the head. And these were ported out before, so now when you open up the valve, you can almost see the whole valve head up under there, which is what you want to see. That way it's not restricted in any way. The exhaust had a lot of work done on it too. You can see how it's pretty opened up under there also. So this will run pretty good. Definitely run a lot better than stock. So he's going to run the P-cams in it for now, and then these are his nice stock ones. And then later on he'll go to the Y-cams, or not Y-cams, he'll go to the sifting cam he has. I forget what grind he had, but he was talking about maybe trying it out for just fun. Walker's bike, we put Ys in there, and we had siftings in it. Took them out, put Ys in there, it picked up a ton of power. But I did a little more work, with just more porting in it, and some other stuff too. Fixed a lot of other issues he had, so, but it made a big difference. But anyway, there you go. So the heads are all done. So next we'll probably do rocker arms, and then we've got to start working on the cases over there. Got to start doing all the honing out all the bearings and stuff, and bushings for the cam cover. That'll be in a couple days or so. All right, that's it for now.